And we're live. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. So, we are going to talk about friction and gravity. Okay? Friction and gravity. So, what I want you to do is I want you to get your pen and paper ready. I want you to pause the video, do the questions, and then check your answers. Okay? Don't forget to do that. Pause the video, try and solve the problem, solve the questions, and then check your answers with me. So let's go. So here's a list of questions. Pause the video, answer the questions, and then play it. I'm going to obviously just answer it. Name 4 types of friction and give an example of each. The 4 types of friction are, hopefully you remember, sliding, rolling, static, and fluid. And I will just tell you an example of each. So sliding friction is the kind of thing that you experience when you're sliding down the slide, or you're sliding on snow, or you're sliding on the sand, or when 2 objects are just sliding past each other. Even if you're pushing a book on the table, that's sliding friction. So it's only when the object is in motion. It's also called kinetic friction. We also have rolling friction, and that's the sort of friction you experience with wheels. We've got static friction, which is the type of friction that you experience when an object is not moving but just before it moves. So it's the kind of force that you need the friction force that you need to actually move an object. Okay, and then fluid friction is what you experience when you're moving through a fluid such as air, gas, or liquid. Okay? B says classify what type of friction occurs between your bike tires and the ground when you ride over cement, through a puddle, and when you apply your brakes. Okay, so here's your bicycle. Of course, you knew I was going to doodle. I always like doodling. I don't draw very good bikes, but that's okay. I'm working on my bikes. I'll just keep practicing. That makes me better, right? Just want you to know that as well. If you just keep practicing, you'll get better. You'll get better at anything just by practicing. I promise. See, the wheel is a bit off, so I'm just going to draw a different wheel. Okay? And maybe you can do your own bicycle. And if you want to, you can send me photos of you doodling. Okay? I would love to see some doodling photos. You can send them to me on Teams. Here we go. Here's a bicycle. And so it's moving over the road. Okay. Oh, we can even make this better. We can make it like 3D. Here we go. Right? It's moving on the road. And as it's moving over the road, there was a puddle of water here. So there is a puddle of water as well. Now what kind of friction is it going to experience? Well, it's going to experience rolling friction for sure. Rolling friction. Why is that? Because it's got wheels and the wheels are moving. Okay? The wheels are moving, so therefore it's going to experience rolling friction. What else is it going to experience? It's going through a puddle, and puddles have water, and therefore it's going to experience fluid friction as well. Fluid friction, which is what you experience when you go through water or you go through the air. So generally speaking, since it's moving through the air anyway, it will experience fluid friction. But just to make it obvious, it's going through water, so it's going to experience fluid friction. Okay? Hopefully that makes sense. Let's go. What happens to the gravitational force between 2 objects when their masses are increased? 2 objects. They have gravitational pull between them. All objects do. You have your own gravitational pull. I have my own gravitational pull. This pen has its own gravitational pull. This computer mouse has its own gravitational pull. This coffee cup has its own gravitational pull. Everything that has matter, that is made of matter, has a gravitational pull. The more mass something has, the more gravitational pull it has, the more inertia it has. So mass is a big deal in physics. It's a big deal in our world. Okay? So the more mass, the more gravity. More mass, more gravity. All right? But what about distance? If things are closer together, they act like magnets. If you bring 2 magnets close together, what happens? The closer they are, soon they will just stick together. So this is what happens. Closer, and then suddenly they stick. That's what magnets do, and this is kind of what happens in reality between objects as well. Now you don't see it. You don't suddenly go next to the wall and you get stuck to the wall because the gravitational pull is so low. You have your own gravitational field, you have your own gravitational pull, but it's very, very, very low. If you want to see it, you have to look at what happens to particles under a microscope, or you have to look at something called Brownian motion. And that is something that is on a much, much smaller scale. So anyway, if you increase the mass, then you increase the gravity, and when you increase the distance, you decrease the gravity. So if the distance is more, then the gravity is less, but if the distance is less, then the gravity is more, right? So more mass or less distance, that means it's inversely proportional to the distance and directly proportional to the mass. So more mass, less distance equals more gravity. Okay? While less mass, more distance equals less gravity. Okay? Relate cause and effect. How are we doing for time? About 7 minutes. That's not too bad. If the mass of Earth is increased, what would happen to your weight? What about your mass? Okay, so here's the Earth, and here's you standing happily on top of the Earth. Now, what happens if we increase the mass of the Earth? What's going to happen to you? Well, let's see. As far as mass is concerned, let's say you have a mass of about 45 kilograms. Okay, so mass of about 45 kilograms. Is the mass going to change? No. Whether you go to outer space, whether you go to the moon, whether the Earth becomes bigger, your mass stays the same. So mass remains the same. Why is that? Because mass is the amount of matter you have. Unless you do a diet or you start eating lots and lots of burgers, your mass is not going to change. Okay, not significantly anyway. So your mass remains the same. But what about your weight? Weight is a force. Weight is a force, and it acts downwards, and it's due to gravity. And weight is actually your mass multiplied by the pull of gravity, so it's mg. So your mass will stay the same, but your weight will change. If you go to the moon, you'll weigh a lot less. If you're on Earth, then your weight is about your mass multiplied by 9.81. If you're in outer space, your weight is 0 because there is no gravitational pull in outer space. Technically there is, but we don't talk about it. So your weight will be 0 in outer space. But in this case, if the mass of the Earth increases, then your weight will increase because the gravitational pull will increase and your weight will increase. Okay. Let's solve these. How are we doing for time? Not too bad. What are the two factors that affect the frictional force between two surfaces? What are the factors that affect frictional force between two surfaces? Okay, so this is one type of surface material, whether it's plastic or glass or metal or wood or rubber. And the second factor is how closely they are pushed together. How closely the surfaces are pushed together. What two factors affect the gravitational force between two objects? Mass and distance. So how much mass they have and how close they are to each other. How does mass differ from weight? Mass is amount of matter. The unit for mass is kilograms. Weight is a force due to gravity, measured in newtons. Okay? Weight is mass multiplied by gravitational pull, and it's measured in newtons. Building vocabulary. Number 4, friction. Which one of those is it? Please take your time, pause the video, and try and solve it. Okay? Number 4, friction. Which one is it? The force opposed objects together. Type of friction that occurs. Nope. Force that one exists. The type of friction that occurs when you that's the one. C. So the force that one surface exerts on another when two surfaces rub against each other. Okay? Rolling friction, that's E. The type of friction that occurs when a wheel turns on the surface. Okay? Sliding friction, the type of friction that occurs when rub sandpaper against wood. I mean, that's an example of it. Number 7, fluid friction, the type of friction that occurs when nope. Okay, so that is B, and then because it says oil is a liquid. Static friction, type of friction that occurs between objects that are not moving, of course. Static means not moving. Number 9, weight. Weight. A measure of the force of gravity on an object. Weight itself is a force, actually. I would argue that gravity is not a force, but weight is. But anyway, gravity, the force that pulls objects towards each other. Okay. So here's the thing. In this book, it says gravity is a force. In the grade 11 book, it says gravity is not a force, but weight is a force caused by gravity. I am more of the idea that gravity is not really a force. So gravity, although it causes a force, it causes weight. Gravity is like a magnet. So, but anyway, for all intents and purposes, for this exam, gravity is a force. Okay? And so is weight. Weight is a force, gravity is a force. Let's move on. How are we doing for time? Nearly there. Write the letter for the correct answer on the line at the left. Right. Number 1. When you swim in a pool, which one is it? Swim in a pool. It's fluid friction. Okay, fluid friction. That was a terrible D. That's better. Number 2. When you rub your palms together, what kind of friction is that? Sliding friction, obviously. You're rubbing them together. Number 3, when you skateboard on a ramp, skateboards have wheels. It is going to be rolling friction. Number 4, when you push a desk that doesn't move. You push a desk that does not move. Which one is it? B. Right. Let's have a look here. What states that the force of gravity acts between all objects in the universe that have mass. So this is called the law of universal gravitation, which has also been labeled as the 4th law of Newton's laws. So there are 3 Newton's laws. Law of inertia, force equals mass times acceleration. For every action, there is an equal or opposite reaction. But for those of you that are nerdy and geeky, the 4th law, kind of like a secret 4th law of motion, is the law of universal gravitation. That's terrible. Universal gravitation. As distance increases, gravitational force decreases. Remember, we said it is inversely proportional to distance. So if the distance is more between objects, then the gravity is less. When you stand on the bathroom scale, it displays the what the Earth is exerting on you. The force, the gravitational force, or the force is fine. Friction acts in direction opposite to the direction of the motion, which is why it's hard to push things. You push things that are heavy and it's hard. You pull them and it's also hard because friction acts in any way. If you push a desk, let's say you're pushing a heavy desk, it's going to be hard because of friction. But what if you pull it? It's also going to be hard because if you push, then friction is pushing the other way, and if you pull, then friction is pulling the other way. Right, anyway, that's friction for you. Number 9, when the irregularities of one surface come into contact with those of another surface, friction occurs. That is literally the definition of friction. If you're not sure, please watch the video on friction. Remember I said it's about the irregularities of the surface. So even though the surface looks smooth, the irregularities, when they push against each other, they cause friction and heat. Number 10, the applied force required to push something across a surface increases as the friction increases. If there is more friction, then you're going to need more force to push things. Okay, hopefully that makes sense. I'll see you in the next one. Good luck.